Ever pondered how data organizes itself within a computer system? Well, meet data structures, the unsung heroes of efficient data organization and storage. They are like the invisible shelves that hold data in place, making it easy for us to find and use. Today we're going to explore 4 types of data structures: arrays, linked lists, stacks, and queues. Understanding these structures can help us manipulate data more effectively, paving the way for more complex operations. Imagine a shelf with boxes lined up. That's an array for you. Arrays are a collection of elements, each identified by a unique index or key. Think of the benefits of using arrays. You get direct access to any element you want, just like picking a box off the shelf. Plus, arrays are memory efficient, making the most of your system's resources. But remember, every rose has its thorn. With arrays, the size is fixed. It can't grow or shrink on demand. Think of a scavenger hunt, where each clue leads to the next. That's a linked list. In this digital scavenger hunt, each clue is a node. Every node carries a precious piece of data, and a clue, or rather a reference, to the next node. The beauty of linked lists lies in their flexibility. They can grow and shrink on demand, and dropping in new nodes or removing old ones is a breeze. But unlike arrays, accessing elements in a linked list isn't as direct. Ever stacked dishes? That's the concept of a stack. A stack is a data structure that follows the last in first out principle, or LIFO for short. Picture a pile of plates. You put one on top, you take the top one off. It's as simple as that. Stacks are loved for their straightforward design and speedy operations, but remember, like a towering pile of dishes waiting to topple, stacks can lead to memory waste if not properly managed. Recall waiting in a line at the grocery store. You were in a queue. Queues in computer science obey the first in first out principle, just like that grocery line. The first element to enter is always the first to leave. This allows for controlled access and efficient operations, particularly when dealing with data streams. Queues serve a vital role in managing processes within operating systems and handling network requests. But remember, queues can also lead to memory waste if not carefully handled. So, arrays, linked lists, stacks, queues all have their unique characteristics. Arrays are simple and direct, while linked lists offer flexibility. Stacks are ideal for last-in, first-out scenarios, and queues shine in first-in, first-out situations. Remember, the choice of data structure can significantly impact the efficiency of your code. Understanding these data structures, you are now well-equipped to make better data-related decisions in your computer science journey. Until next time, happy coding!